One of the main goals in business and economics is to maximize profit. So, given the revenue and cost functions of some commodity, how can we determine the level of output that maximizes the profit? Well, the following example illustrates how we can do this. Suppose the total daily cost of producing running shoes is given by C of Q equals negative 0.1 Q squared plus 90 Q plus 200. The revenue earned from selling Q shoes per day is given by R of Q equals negative 0.35 Q squared plus 120 Q. We want to determine the daily production level that will maximize the profit. To do this, we need to set marginal cost equal to marginal revenue and solve for Q. If C of Q is the cost of producing Q units, then the marginal cost of the Qth unit of output is the limiting value of the quotient C of Q plus H minus C of Q all over H as H approaches 0. Putting this into the formula, expanding and collecting like terms and simplifying gives negative 0.2 Q minus 0.1 H plus 90. Then as H approaches 0, this equals negative 0.2 Q plus 90. This is the marginal cost of producing the Qth item. Similarly, we want to find the marginal revenue of selling the Qth item. So if R of Q is the revenue generated from the sale of Q units, then the marginal revenue from the Qth unit is the limiting value of the following quotient as H approaches 0. So working in a similar way, this equals negative 0.70 Q plus 120 as H approaches 0. Now profit is maximized when the marginal cost equals the marginal revenue. Solving for Q gives Q equals 60 units. So 60 units will maximize the profit.